3.2, which is a continuation of trigonometric ratios. In the previous section, we were interested in finding the sides of a right triangle. In this case, we were always given one of the other angles, we'll call it theta, and one side. Using our trigonometric ratios of sine, cosine, and tangent, we were able to find the other sides, and using the property of triangles, knowing that all angles add up to 180 degrees, we were able to find the other missing angle, often called phi. In this video, we're going to look at finding angles. The information that's going to be given in these types of problems is two sides and the right angle only, the 90-degree angle. So for instance, if I quickly draw a right triangle here, I'd be asked to find theta, and I would either know x, y, or maybe the hypotenuse, we'll call it h. I'd know two of those sides, but not theta, which means I can't find phi yet until using the 180-degree rule. To do this, we're going to use the inverse trig functions. Let's take a look at another right triangle. Let's say that I don't know theta, but I've been given two of the sides, the opposite side and the hypotenuse. Remember, opposite is always away from the angle. I also know that this is the right angle. I can write the expression for the sine of theta. I know that sine involves opposite over hypotenuse. So the sine of theta is equal to 3 over 5. The only unknown in this equation is theta. But I can't simply just divide by sine, because sine theta is a function all by itself. So sine and theta go together. I need a new way to separate sine from theta. And we can do that using the inverse of sine. So this equation, to solve for theta, is going to look like this. Theta equals the inverse of sine, which is denoted with a superscript of a -1. And I take whatever was on the right-hand side, in this case, 3 over 5, and I put it in parentheses. Now instead of taking the sine of theta, I'm taking the inverse sine of 3 over 5. Again, your calculator should be able to handle this. Often you should use the shift button or the second button on your calculators and hit the normal sine button, and that will take you to the inverse of sine. The inverse of sine is approximately 36.9 degrees. Likewise, we can define the inverse cosine function, the inverse tangent function as well. Remember that cosine is adjacent over hypotenuse, and tangent was opposite over adjacent. We'll throw in sine here to be complete. The inverse of sine looks like this. Remember that the sine of theta is opposite over hypotenuse, so the inverse sine is this expression. And now if I'm given any two sides of a right triangle, I can find the missing angles. And once I know theta, I can quickly find phi by subtracting theta from 90. I also quickly want to review how to find the third missing side. We'll call it x. Remember that we can use Pythagorean theorem here, which states that a squared plus b squared equals c squared. In this case, c is always the hypotenuse, and a and b are the other two sides of the right triangle. Remember, Pythagorean theorem only works for a right triangle. Well, in this example, I know the hypotenuse, and let's say b is the opposite side, so I'm missing a, or the adjacent side, which is x. Doing a little bit of rearranging and plugging in, I see that 5 squared minus 3 squared equals x squared. Now if I plug that into my calculator and do some simplifications, I should get x equals 4. Again, this should be review, but here it is if you need to see it. Let's take a look at a few examples. I've been given a right triangle, and I want to find the missing side, which in this case is the hypotenuse, and theta. Well, the missing side's the easiest part to find. We just use Pythagorean theorem to find x. In this case, x is the hypotenuse. So remember that we have 7 squared plus 4 squared, these are the two sides of the triangle, equals the hypotenuse squared. Well, 7 squared is 49 and 4 squared is 16, so I have 65 equals x squared. Don't forget to take the square root to find x. So x is approximately 8.06. And don't forget the units of meters. Next, to find theta, I need to choose the appropriate inverse trig function. Well, I'm given theta, and I know the opposite side, which is 4 meters, and I know the adjacent side, which is 7 meters. So remember that tangent theta equals opposite over adjacent. And the inverse tangent is written like this. Well, again, I know the opposite and the adjacent side, so all I have to do is plug in the numbers here. And take the inverse tangent of 4 over 7. If I plug this into my calculator, again using the shift or second button, I get theta is approximately 29.7 degrees. Let's take a look at one more example. Here we're not going to find the missing side, we'll just find theta. We know that theta equals, cut this, we've been given theta, cut. Let's take a look at one more example. In this case, we're not going to find the missing side, we're just going to find theta. Again, it's always helpful to label the sides. This side over here is opposite, which means this side is the adjacent side, and the longest side, again, is the hypotenuse. So I need an inverse trig function that solves for theta using the adjacent and hypotenuse sides. Well, we know that this is going to be the inverse cosine. So theta is going to equal the inverse cosine of adjacent over hypotenuse. And then I can just plug in the numbers. We have 2.67 over 5.92. Using my calculator, I find that theta is approximately 63.2 degrees. Again, remember that your calculator should be in degree mode, not in radian mode at this point. We'll talk more about radians later.